We are Work Smarter, Not Harder. This is our Design Phase 3 presentation. I'm Dominic.
I'm Philip. I'm Easy Money.
Alright, now, moving into our introduction slide, we're going to have for you in this presentation our updated project management, our concept development, all components, our CAD model, images that give you an idea of what our project looks like, an FMEA, and a demonstration at the end. And now we have Philip to talk to you about project management.
Hey guys, so for this project management update, we updated our Gantt chart with the things that we completed in DP3 that were different from DP1 and DP2. We also updated it so it showed that we completed everything from DP1 and DP2, including all our concept realization, like the concept modeling, concept testing, FMEA analysis, and then the DP3 additions were product architecture, industrial design, and design for manufacture. We found, also prototyping. We found that the prototyping step of the planning process was the most useful in our concept generation and us making our product. We found it hard and difficult to conceptualize all the little intricacies of how everything gets put together beforehand, especially with the CAD models. And each step made it a little bit easier, but the prototyping stage was really when we hammered out all the little details and got everything working together, which was really nice. Next, we're going to have Design for Environment by Easy.
Design for environment. Our BRG machine is designed to be environmental friendly. Our goals include using more recyclable materials and reduce energy used, or we want to use more green energy to reduce the pollution for the environment. Although our product is designed to be environmental friendly, it still might cause some potential impacts for environment. For example, we use 2 batteries in our system, and after using it, the batteries might cause pollution to the environment. And also, we use Arduino too, which might be electronic waste. And also, during the manufacture process, we use laser cutter to cut the wood pieces, which is a huge energy consumption. And for product architecture, our design is highly modularized. Each obstacle serves as a chunk, and the type of the modularity is slot modular architecture. And from the picture on the right, we can see that each obstacle is connected by one base. We just use a foam board as a base and cut holes in it, so we can put different obstacles. Each obstacles work independently, and we can replace one obstacle with another one if we come up with a new idea. And also, for each single obstacle, the components can be detached very easily because they are fixed by either screws or rubber band. And for our industrial design, we evaluate the performance of our BRG machine. For the first criteria, quality of the user interface, the performance is between medium and high, because for obstacle 1 and 2, it's kind of hard to set up. Because it requires highly precise operation to set the trigger up to make it sensitive enough. And for emotional appeal, the performance is pretty high because we have awesome appearance for the BRG machine. And ability to maintain and repair is also high because each part can be detached very easily and do repair and maintenance. Appropriate use of resources. Our machine consist most of environmental friendly materials such as wood and wires. They can be reused and recycled. And since our DP3 machine has a very unique appearance, it can be distinguished very easily from other competitive products, so that it has a high performance for product differentiation. Next, we have Philip to talk about assembly time and cost sheet.
Alright, so for our assembly time, we looked at every single obstacle, and we looked at all the individual components that made up that obstacle. For each obstacle and each part, we looked at the alpha angle and the beta angle, which is the rotation. And using those data points and how everything fits together, we used these two tables to determine our total assembly time. And the final number that we got was 13.5 minutes using those tables. We found that this was probably an underestimate of the total time that it would take to actually put this project together, especially for one person putting it together. For us, it definitely took longer, but that was mainly because we had to figure everything out individually, see how it worked, and then change it as things didn't work or did work. But even if everything was laid out perfectly, we feel like that it would take a little longer than 13.5 minutes to put everything together. But using the 13.5 minute number and a $20 an hour wage for an assembly line worker, we determined that our assembly cost would be about $4.50. Next, our material costs. We looked at each of the materials that we needed for this project. And we researched on Amazon, Home Depot, Lowe's, and those kinds of places to look for purchasing these products, because that's where we got them. So overall, our material costs came out to $69.34. We feel that is an overestimate because of a few factors. One is we were buying consumer products, which are going to be marked up from the big box stores like Home Depot and Lowe's. And also, we were not buying in bulk, which generally speaking, especially if we're making a lot of these projects, we'll be buying most of these things in bulk, which will lead to a cheaper price per unit. Our highest cost items were the Arduino and the neodymium magnets, both of which we could probably save some money on, especially buying in bulk, but also with the Arduino, possibly using a smaller unit that doesn't have as much functionality, but does what we need it to. Next, we're going to have Dom explain some of our CAD models.
Alright, over here we have an isometric view of our entire project and an orthographic view of our front, side, and top angles. Now, our ping pong, this all fits onto a 20 by 30 inch film board, and it is all modular, assemblable, as Easy Money has pointed out to us earlier. The ping ball starts here, it hits the magnet, which will send it through the coil, activating our launcher. The launcher will then fling a ping pong ball up the ramp, which will knock out and activate our catapult. This catapult launches the ball into the funnel, which will then exit through the tunnel, propelled by the fan. Going more in depth on the measurements, our coil is approximately 7 inches long, and the battery going through it is almost 2 inches. Our launcher is 8 inches long, and it propels the ball up a 10-inch high ramp. The 10-inch high ramp goes to the 10-inch high catapult, which is then flung up and reaches a total height of 2 feet. From this 2 feet, the ball is dropped down into the funnel, where it exits through the tunnel, which is as long as it needs to exit the foam board. Now we're going to come back to Philip to talk about the FMEA and the future changes of this product.
Alright, so we looked at our entire project as a whole and did a failure mode and effect analysis, FMEA. We found some of our highest risk items were the trigger mechanisms, because they weren't quite as reliable. The rate of occurrence was pretty high on those. So in the future, that is definitely one of the parts of the project that we would work on, probably change, but at least improve on to make them more consistent, and so they don't misfire, and they go every time a ping pong ball hits them. Also, we would look at adding more aesthetic appeal to our project. Right now, we have our instructions laid out. We have some pictures, some very simple pictures, but it's also still very bare bones. And we look at adding more color and making it more distinguishable from other projects so that we have better market appeal. Lastly, we would also look at replacing our most expensive items, especially the Arduino. Like I mentioned earlier, we don't use the Arduino to its full functionality, and we could probably go with a smaller board so that we don't have to pay quite as much for the Arduino. And lastly, in our conclusion is we stayed on track with our project timeline. We developed our past work from DP1 and DP2 and improved upon it. We also finished our concept development and testing, as you can see from our project. And our full economic analysis is completed with the addition of the cost sheet and assembly times. In conclusion, we have finished this project successfully, and we would look at starting to manufacture if VTEPs would give us an investment. And that's it.
Oh, okay.